So a big subject for us these days is a thing we call space weather, which sounds a little bit strange, but it's basically understanding the environment around the Earth and the impacts in particular within that environment that come from the sun. Because the sun throws things out into space, huge clouds called coronal mass ejections, the solar wind, which is a continuous outflow of plasma, charged gas from the sun, and huge explosions in the sun's atmosphere known as solar flares. In 1859, a huge event erupted from the sun and headed our way, and we didn't even know such events existed. And there was an enormous impact in the sense that the aurora lit up dramatically around the globe, and on top of that you had hideous reactions in a sense in things like the telegraph systems on the Earth. Now if you imagine a system these days, an event like that these days impacting the Earth, it'd be actually quite severe in terms of possible impacts on spacecraft or power distribution systems, navigation systems, a whole host of things in a sense that contain some sort of price tag or impact that we might worry about, or that governments might worry about in fact. On top of that, of course, you have the beautiful sight of the aurora lighting up as one of these clouds comes through and impacts the Earth. But the bottom line for all of this is we need to understand how the sun works in the same way that a weather forecaster, you'd expect them to tell you whether it's going to rain. We want to know if one of these clouds is approaching the Earth and what it might do. So we need to understand how the sun works in far greater detail. And one way to do that is to get a spacecraft to go close to the sun. Solar Orbiter is a mission of the European Space Agency. We had a meeting in 1997. 5 of us met in a room at the European Space Agency in Noordwijk in Holland to think about what the next generation solar mission should look like within the European Space Agency. And that ultimately led to a concept for a mission to get close to the sun, because the idea is that we've studied the sun from Earth, near the Earth, around the Earth. You get this same view all of the time. To get up close obviously gives you extra information. It's the same way as flying past a planet or the moon or whatever. It's like an encounter mission, but it's to the sun. You're not going to land on the sun, but you can get pretty close. So the idea was to get up close, find a way of getting instruments closer to the sun and getting data back of the sort that we've never seen before. So it was actually proposed to the European Space Agency in the year 2000. And for me, it's been a long, long haul because I was involved right from the beginning. And to see it come to fruition some 23 years later after the initial concept is a wonderful thing to see. But it does stress how long it takes to devise cutting edge stuff like this, to build these new instruments and design a mission that gets so close to the sun where thermal issues are a real problem. One of the key instruments that will be flown aboard Solar Orbiter is an instrument called SPICE, which stands for Spectral Imaging of the Coronal Environment. It's actually an instrument that we've built here at the Rutherford Appleton Laboratory, which is a laboratory of the Science and Technology Facilities Council. And it was a natural instrument for us to lead because we've developed solar spectrometers over the decades in various flights, but Solar Orbiter will take one close to the sun for the first time. So what is a solar spectrometer? The idea is it's an instrument that basically looks at the spectrum from the sun. It's a bit like looking at a rainbow, but in ultraviolet light. So it's light that you couldn't see with your eyes. It splits up that ultraviolet light. You can actually see patterns in that light when we're looking at the sun's atmosphere. And those patterns will actually tell you what the sun's atmosphere is made of, the gases in the sun's atmosphere, or more correctly, plasmas. They're charged gases because they're super hot. And we can measure the temperatures, we can measure the densities, we can see how the gases are moving around the sun's atmosphere. And these are all things that you need to be able to really understand the physics of the sun's atmosphere and what's happening in there. And you use that instrument along with imaging instruments and instruments that do various other things and the particle instruments that measure things flying over the spacecraft to piece together what is actually happening in that environment in the sun's atmosphere and how it feeds out into the heliosphere that we live in.